Okay, so let's say we're given a curve like this, okay? And actually, let me go to this right now. Okay, so we have a curve like this, and let me just set this up so we're only looking at what really matters. 0 to 2. From 0 to 10. Okay, so our interval we're going to be working with here is going to be x is everything greater than 0. So we're actually going to flip everything. So this empty space is our little area we're going to be working with. So we're going to be using the midpoint rule. All right? And so what the midpoint rule is, and I'll move this out of the way. Move it over here. Okay. So I can't even spell right. Midpoint rule. Okay, so what the midpoint rule is, so of course when we have, so we're working with an interval of 0 to 2, and so over this, of course, we know that delta x, let me rewrite that. Okay, that's fine. So delta x is basically the size, or the base, I like to call it, along the x-axis of our rectangles. Okay, and that usually goes from point B, which in this case is 2, minus A, your first endpoint, which is 0. So it would be basically, and we can just translate this over, 2 over the amount of rectangles you're going to use. In this case, we're going to use 2, or this would be technically n, so 2. And so that equals 1. So our delta x is 1 in this situation. Okay. Just get rid of all this. Okay, I guess that's a lot faster. Anyway, so we are going to, so normally what we would end up doing was we would have rectangles either going from the height of the left-hand endpoint, and let's say stopping here, and then it'd be something like, oh, I messed that one up. Then it'd be something like this. And then so you'd severely undervalue. Or if we had an oversum, or a like right-hand endpoint one, you'd end up with one that vastly overestimates the actual area under the curve. And so the point of the midpoint rule is that it is a halfway kind of point, I guess, when you estimate. So if your delta x stops here at 1, as it does in this case, you are going to find the midpoint from each of your, you're going to find a midpoint from each of your endpoints you'd be using. So in this case, it's simply a very simple one of just 0, 1, and 2. And so I will actually switch colors for the midpoints. We'll go to a blue. Okay. So the halfway point between 0 and 1, of course, is 0.5, and the halfway point between 1 and 2 is 1.5. And so The midpoint rule shows us that we go across our entire delta x when we're making this rectangle, but we stop at the height of the midpoint. And so the same occurs over here. So instead of stopping at the height of the right-hand endpoint or the left-hand endpoint, you're stopping at the midpoint. So once again, the entire delta x occurs. And then we stop at the height of the midpoint. And you can see you're not as grossly, so I can also go back and I will compare. So in green we will have, if you were to do the left-hand endpoint, alright, so that's not up again, oops. And you can see how this is much closer to the actual value than if you were to do the left-hand endpoint. And then in, I suppose we can do yellow. We've got the right-hand endpoint, where it would be something like this. And then something like this. So you see that the midpoint rule gives us an answer much closer to the actual area. So now if we were to actually calculate this area, we can find that if we go to, so x3 plus 2, if we were to plug this in, oh, what did I just do? There we go, okay. So I will, is there a way to save? We'll just quit, okay, whatever. So basically, we're going to go here, and I probably should have done this earlier. So the height at each of the midpoints, minus 1.5 and 1.5. So these were our midpoints we found. Oh, no, 0.5, not minus 0.5. So, of course, our midpoints here. So now, what we would do, also pull this up one more time. Sorry if I am kind of beating this to death. Go here. So you go over to delta x, stop the height of the midpoint. Delta x, stop at the height of the midpoint. And now you do some quick maths. So you have, of course, a delta x of 1 here, so it is 1 wide. And your height is about this 2.125. So I am gonna... So we can just write this here, I guess, 2.125. And then we'll add that to the area here. And so the height at 1.5 is not a whole lot better. I suppose I could have just typed this up. 5.375 is the height. And of course across it is also 1 because that's our delta x. So we're going to end up getting this little formula of 2.125, of course times 1, so it's just the same thing, plus 5.375. And then this would give us our estimated area. And so when you add those together, mentally, I believe it is a 7.5. So this would be your answer using the midpoint valuation of to estimate the area under a curve. And that is a lot closer, of course, to the actual result than if you were to use the left or right hand endpoints. So, thank you for watching, and make sure to check out the other videos I put out in the future.